Alright, hi again, Rizal. So we've got to the point where we've got the equation. And we've got a second order differential equation to solve. And judging by what he's given you in the assignment from before, he's asking them to use maple. It's pretty hard to put this equation in anything, to be honest. And I've tried a couple of different options. So the one is the website Symbol Lab that we've looked at before. I had difficulty putting it in there because it just came back that it couldn't solve it, even if I chose second order differential equation. It just said it had no steps on file or something like that. So I went to Wolfram Alpha, and if you search like second degree differential equations, it'll come up as one of the hits. Now the only problem I'm having is I'm trying to put the equation in here. Let's see if I can make that a wee bit bigger. Why doesn't it want to help me? Oh, there we go. Okay. So I'm trying to put in, like, you know what equation we're trying to put in here. 2x, and so the d squared y dx squared is y double prime for a lot of the websites. So this one in particular, that's the easiest way to write it. Equals, and then we want negative the square root of bracket 1 plus, and that's y prime squared. So that's all that has to go in, but when I put that into this one, it took the left-hand side, but this one works a little like maple, where it's not reading what I'm trying to tell it to read. So I tried to use brackets for this part so I could get the 1 plus the derivative squared, and then I bracketed that off and tried to put it to the exponent 1/2, which is the square root function, with a negative in front. And it didn't read it that way. It read it. I took the square root, and it's got the 1 plus the square root function, or the derivative, but it's got it times an x squared in there, and I don't know where that came from. So, and I don't know how to tell it different, but if you play around with it, you may be able to convince it that you don't want an x there. You want the squared on the derivative function on the y prime. If you can do that, then it looks to me like it's going to spit out the right answer. I've got to go. I have an appointment in a little bit, and so I can't play with this right now. So I just thought I would kind of present that to you to play with if you have time. See if you can find a differential solver. If you have Maple on your computer, you might want to try putting it in like I showed you here and see what Maple does with it. And then the parameters that he's giving you in the assignment, which come from your assignment as well as the one that you found with the solutions. The parameters are that dy dx equals 0 when x equals 0, or when x equals 1 and y equals 0, right? So dy dx equals 0 when x equals 1 and y equals 0, okay? And so at some point along the line that gets substituted in to simplify the equation so that you can get an answer. Now, one thing that he hasn't answered on his assignment when he did the solution was, the question was how far along before they crash into each other, right? And he didn't do that. That point is going to occur at x equals 0 and y equals some unknown value, because y will be the distance along the y-axis that it's traveled before they meet. And so you're going to set in your differential equation, when you solve that equation, you want x to equal 0 so that you can get the y value out of it, and that'll tell you how far they've gone before they meet. So I'll give you that much to work on, and if I can later, I'll try to get back to it. I just have to go out this afternoon. So I'll give you that to work on and see what you can do with it. I think the point that we got to is probably further than most people are going to be able to get to on this one as it is. But if you can find a differential equation solver online or using Maple, and you can get to the point that he did in his assignment, you probably want to reference that and let him know how you got it so he knows you didn't copy it from his solution. Okay?